we have the pleasure of having Dr. Chetan Gupta, head of Hitachi Industrial AI and the Global AI COE. We've had the pleasure of working with Dr. Chetan's group here in the Bay Area, and they've really been pioneering from a very early stage this need for domain knowledge in combination with AI to solve a lot of the industrial problems. So him and his team have developed solutions across, you can imagine, a pretty extensive Hitachi global footprint for mining, energy management, transportation, and logistics. So Dr. Chetan, the floor is yours.
Thank you. So I have the honor of being the last speaker, and I would like to believe that you guys stayed up for me, but I'm sure that's not true. You're waiting for the party. The other disadvantage of being the last speaker is everything that's worth being said has already been said. But anyways, I'll try to sort of at least give you some new ideas. So I used this slide last year as well. And for folks who were not here last year, just to wake you up, can you tell me what's common in all of these? And I have a point to make with this quiz, I promise. So in all these things that you see, what's common? Color. Machines. Camera is not necessarily a machine, really. It is? Okay, so I'll tell you what's an alarm clock is not a machine. Okay, so what's common in all of these rather, is they contain a motor. So if you think about it. And I will use this point again later in the presentation. It sort of relates to Hitachi's legacy also, which started off as a motor company, now does a bunch of things. But the point that I made last year was that very soon, AI will be everywhere. And in some sense, I didn't anticipate that it will be so soon, right? So last year when we were discussing AI, applications of AI, it was still, in some sense, adoption of AI in the industrial space, the awareness of AI in enterprises was still low. Now today, the CEO and the CTOs and everyone wants to know what's happening in AI, what's generative AI. So besides the actual use case of generative AI, which I think are still very much in the POC stage for very many applications, the hype that it has created has sort of elevated the discussion about AI in multiple organizations. So that's the first thing I've observed over the last 1 year. And I noticed the password to the Wi-Fi is industrial AI, and no one really mentioned it since morning. So I thought at least I should mention and define what industrial AI is. And so I have a narrower definition of what industrial AI is, right? So in my mind, industrial AI is, this is a bad choice of colors, but application of artificial intelligence, machine learning, and related technologies towards addressing real-world challenges. But more specifically, the use cases that we had worked on for last very many years before generative AI upended all our lives was around maintenance, repair, operations optimization, quality assurance, supply chain management, automation control. And where we really want to get to is end-to-end optimization. But you will see that many of these fields are sort of untouched by many of the use cases that we heard today from generative AI. And my intention today was to sort of give a talk on the intersection of generative AI with industrial AI. But I was preparing for the talk, I found that intersection to be very small. But I'll do my best to sort of explain some of these concepts to you. So this is again a slide from last year, and just to the point that we had sort of discussed this, and we thought AI will be ubiquitous by 2025, but in some sense this has been short-charged, and now in 2023, AI is everywhere. And this is not a coincidence, right? So this, it's at every few years we see a major technology wave, and now it's turn of AI. But it's important to note that these 2 points are still very relevant from last year. One is that corporations that don't master a new technology will mostly vanish out. And it will touch every horizontal, right? And with generative AI, horizontals typically that were untouched by AI, like sales and marketing, also are being touched now. And so coming back to sort of the topic of generative AI, right? And this is taking a slightly broader view, and I say enterprise here. and not necessarily industrial AI. But I just wanted to put it here. So the way because Hitachi is a very big corporation with multitude of different BUs and very different sort of objectives in terms of what they do. And so if you talk to people as to what they want to do with AI, this is the sort of categorization that I use. So a lot of people want to get the ChatGPT experience within the enterprise, right? So why can't I use ChatGPT-like interface to do knowledge management kind of stuff? And in some sense, they want it for everyday tasks, like send my email, or create my email, or create the marketing material, create a summary of the stock, create the stock itself. I promise I did not create the stock with generative AI. But the point being, this is where everyone is. Then from an organizational perspective, executives are very interested in knowledge management, right? Because, for example, I'll give you a very simple example in Hitachi internally. Hitachi is a global organization. Hitachi Rail is headquartered somewhere in Europe. And even for very senior leadership in organization in Europe, it's still difficult to know exactly what's happening in Japan because a lot of documents are in Japanese, right? Very straightforward, right? So then can I create an interface wherein I can ask some bot in English or in my native tongue, Spanish or Italian or whatever it is, about something, and I get an answer based on documents that are within the enterprise, right? So that is sort of the next level of use case around knowledge management. And then the way I think about the world is number 3, in terms of everything where we get value is through process transformation, right? So if you take a step back and see how AI generates value, typically it's process transformation. So Feng, in the previous talk, talked about software development. So essentially what you're doing is there is an existing process for software development where if I'm writing code, if I have to write a certain piece of code, I'll used to manually search for relevant code if I don't remember how to write that. Now, instead of that, I have a chatbot or I have a bot which can generate the code for me. So all I've done is in my whole code writing process from morning till evening, I found one step that I could automate. And that leads to all sorts of value creation. So for a lot of industries, if you look at their core processes and you ask yourself, what is one step that I can transform, that can automate, and that will give the most value to any organization? So these 4 areas, software engineering, customer operations, marketing and sales, and R&D is something that I sort of missed. They were identified by McKinsey. This is not my intelligence. But they believe these 4 areas will have the most transformation. And I think the way to think about it is to study the existing processes and see which step in the process is ripe for transformation. Where we are not yet here is coordination across business value chains. And this is sort of the holy grail. So someone had mentioned, I think, AutoGPT in terms of the number of downloads from GitHub. And I believe this is still going to be difficult, but can I orchestrate multiple processes in an automated way using AI to sort of do whole-scale transformation, not of a particular process, but a set of processes? And this is something that, from a research standpoint, we are working on at Hitachi. So I think people have gone through this in the morning. So I just want to say that these are the different sort of design patterns that we use, from prompting, structured prompting, RAG, model pre-training, fine-tuning, to training from scratch. And although, in some sense, prompting and structured prompting are not so sexy, they also have a lot of value. And within any enterprise, as you architect a generative AI stack, it's important to enable all of these, right? So you cannot say, I will only do this, only RAG is important, or only I'll do additional pre-training. But from an organizational standpoint, the whole stack is important. In particular, though, if you want to use primarily enterprise data, then you have to go to step 3, 4, and 5. By that I mean, so if you really want to use enterprise data, then the top 3 is what you need to do. And in some sense, this is a slide I made for my executives that I reused here. And I think this is very true, that public data is just tip of the iceberg. So all the nice and fancy things that you do with ChatGPT and your favorite sort of open LLM or accessible LLM is not where the knowledge resides, right? So the data in the public domain is sort of a smaller view of the overall data that exists in the universe. and a lot of the data is locked in the enterprise. And from an enterprise standpoint, I need to access this data if I really want to make use of generative AI, right? And today, the most two popular patterns outside of building your own large language model, which can be prohibitively expensive, and given the shortage of GPUs, not even possible in very many cases, is these two, right? So either you build an RAG over LLM, or you build a domain-specific LLM, and as Arithmetic calls it, small models, right? And I'll get to the size factor in a minute. But I think everyone understands that, but it's sort of visual description of how these two paradigms work. So if you're doing RAG, all you need to do is you create a prompt. The prompt can be of different length, context length. Then you retrieve your data using whatever retrieval technique you want, retrieval database that you want. You give that retrieved document to an open LLM, which will create an English language answer for you. And that's how, at a very high level, RAG works. There are different choices that you can make at every step, but this is how it works. And obviously, if you make a domain-specific LLM, the idea is you take some open source LLM, you take 7 billion Llama, or you take 180 billion Falcon model, doesn't matter. You take that model, you take your enterprise data, and you say, okay, let me do additional pre-training. And with additional pre-training, you get a domain-specific model, and voila, now you have your own language model, right? So these two are the basic paradigms if you want to use your own enterprise data with sort of language-based generative models. I want to point out the pros and cons of this. So the RAG thing is, it's not very simple. It's somewhat straightforward to use. There are a lot of open source, publicly available libraries or tool sets or tool chains that you can do for RAG. And with RAG, you can always access the latest data. I think in the earlier talk, there was this option of real-time versus static data. So if you have real-time data, then RAG really becomes, for now, the only viable option, because there's no way you're going to train your large model or small model every time there is new data. But the thing that people don't realize that there is a cost of operations. So right now, we're all living in a world where there are a lot of free goodies, right? So for $20 a month, you can access ChatGPT. I don't know how long that will last, right? So people think that search, for example, will be replaced by something like what ChatGPT does. But if you think about the cost that Google has to pay for one query versus cost that OpenAI would have to pay for one query, it'll be drastically different. So if you start thinking about real enterprise issues like cost, then you have to sort of start thinking, which way should I go? So anyways, the high cost in operation because the context size, larger the context, more expensive your query is going to be. And once you start thinking of multimodality, RAG runs into sort of technical difficulties, which I think can be overcome over time, but multimodality is still a challenge here. For a language model, obviously the development cost is very high as a negative, and you're looking at static data. But what we have noticed is that if you want very precise answers over a very large corpus, then your own domain-specific models outperform RAG. So it's again a sort of application-specific, how much precision you want in your answer, and that's where it wins. And in operation, it's low cost because you're not giving the whole context every time, unlike with RAG. So it can be much lower cost to operate, and it can be application independent because think about GPT-4, you can ask all sorts of queries to it, and you can get all sorts of answers. So it gives you one short way of developing, of using generative AI. Rather than RAG, you'll have to construct a different kind of query every time for every different kind of operation. So I'm back to this figure. So what is this telling us? That is very relevant to this discussion. Okay, in interest of time, I'll give the answer. All of these motors are different sizes, different horsepower. They work in different conditions, right? So Hitachi started out with making one 5-horsepower motor, right, for mining operations. So today, that's where we are. So we have this notion of a very large LLM. And we believe that one large LLM can solve all problems. Right? But I think this is only the beginning of the journey. Right? Someone said we are mile 1 of mile 26, early in the morning. And I think this is what this sort of slide is trying to tell you, is that for different use cases, we'll have to figure out what are the different, what is the right choice of the model, what is the right choice of the application stack. And so that's why there is a lot of work that needs to be done. So although right now it feels that ChatGPT is overwhelming, it will do everything, solve world's hunger, but that's not really going to be the case. So that brings me to this, this plot. And this, the left-hand side is speculation, because right, they're definitely not orthogonal. But if you think about any task that you want to, any goal that you want to accomplish, there are three things. There's a language part, there is the domain part, and there is a task part, right? Suppose I want to answer a question very specific to the energy domain, right? The language model will need to contain the information of that domain, right? So that is where the domain part is. So it might contain the information of the domain, but does it have the natural language to express the answer, right? Suppose I say, ask it to construct the answer in the format of Shakespeare, right? So does the language model, so does it have the ability to create that language which resembles Shakespeare, right? So that is the language part. And the third is the task part, right? So once you sort of disambiguate your goal into these three axes, then it becomes somewhat easier to think about what is the right model size, right? So on the right-hand side, so you have this all model which does everything in the world. And then from then you can sort of go to different domains and for different tasks. And what is the right abstraction for you, right? So do you want an all model, or do you want a domain-specific model, or do you want a domain and a task-specific model, right? If all my questions are about energy, do I really need to know about Olympics, right? No, not necessarily, right? Does it need to translate from English to French? Maybe not. So it's very important to take a step back and think about what is the right abstraction for you for a number of reasons, for cost reasons, for efficiency reasons, for maintainability reasons, and all of that, right? So this is sort of one thought, I think, where the automatic people and we think similarly, right? So what is the right model size for you to think about? So I'll keep going on. These are some sample use cases. And so that we have been working on internally. And these are back to the industrial domain. I want to bring this talk back from enterprise to the industrial domain. So one is fault-free extraction and repair recommendation, right? So people who have worked in any kind of industry or in the maintenance shop, fault trees are very important because they help guide you what repair needs to be done. So if you see something is wrong, can you take that symptom and then drill all the way down to what is the right repair, right? So these knowledge is often embedded in very large manuals. And the ability to extract a fault tree from the manual, typically today is done by domain experts. So this is a very deliberate process of creating a fault tree, and then those are used by people who maintain these equipment or processes. And since it is so expensive to do that, you don't always find the fault trees in existence because it's expensive. So the idea is, could you come up with some framework or by which you can automatically generate these fault trees given a manual. Number two is industrial AI QA bot. This is a fun project. So we have an industrial AI course. So you can learn all about industrial AI in that course. But anyways, we developed a bot over it, and sort of it evolved from there. And now it sort of answers simple questions about your industrial challenges. So for example, if you ask, how do I improve the efficiency of a mining process? If this is the challenge, it is a very small model, but it will compete with GPT-4. And this is an example of domain-specific knowledge, because the only thing it really knows is those few things it knows. So if you ask a question in a simple language, it will do well. If you ask it an MCQ kind of question, it will completely flop. But the idea, again, is I don't want this model to do MCQ. I want this model simply to answer very simple questions in a limited domain. Then service manual QA bot, as you can imagine, this is very similar to number one. And this is around service manuals. And then integrating metaverse with generative AI for the industrial world. This is something we're quite keen on. So I know Facebook gets a lot of attention for metaverse, but I think there are a lot of interesting applications of metaverse in the industrial domain. And I think generative AI, metaverse becomes an interface over generative AI. So for example, I have this room, and something goes wrong with the screen. Then in the metaverse, I can render this, and I can sort of put all the information that I need to repair this particular screen in the metaverse, right? If someone technician is remote, and all that knowledge is being generated through generative AI. So this sort of notion of combining a metaverse with generative AI is very interesting, I think, as well. Where we are sort of what's in the red box is more of a research questions that we're trying to ask. So a lot of industrial operations are based on response to anomaly, right? So typically, if you think about your car, you're driving your car, you don't really think about it till something goes wrong with it, right? That's for most things in our life, including our relationships very often, unfortunately, right? But the point being, but there is so little data about that, right? So there's a lot of data for normal operations, but there's very little data about anomalous operations. So then can you use generative AI to generate data for anomalous operations? And this can be image. For example, we're using it to generate defects in equipment. It's for acoustics. So there is, when I was in my very first job, there was this guy, this was in a chemical plant, chemical refinery, had a stick that he used to hit the pipes with. And believe it or not, he would know which pipe has a crack in it, just by hearing the noise. They are so good at what they do. And people do that. So acoustics is a very common modality in industries to find anomalies. But again, the problem is that data is not sufficient, right? So then can use generative AI to generate this anomalous data for different modalities. And then we are building industry-specific domain knowledge and models, which is sort of an interesting challenge for us. I wanted to give you one example of how we sometimes think about industrial applications of generative AI in the supply chain management. So these are some of the horizontal functions in supply chain management around product design, procurement, production, logistics, customer operations, sustainability. And these are the main language tasks. So it's very much limited to language right now, but summarization, Q&A, content creation, scenario generation, and it's not a K by K matrix, but there is, if you think about each of these tasks, you will see at least for some of the horizontals they will fit. For example, scenario generation is very important when you're thinking about building a simulator for your logistics and delivery, right? Especially if you want to think about what can go wrong with your supply chain. So this is another very interesting thing, and this is back to the point I made earlier about process, right? So if you can think of any industry as a set of processes, then can you transform those processes? But very often what you find in enterprises is nobody knows what the process is, right? So no one has tabulated the process. There's no way to know today how something gets done. It's in someone's head, right? So this is someone's head. It is in that organization. So what you really want to do is use generative AI to maybe extract that information. So I can go interview someone or tell me, how do you do this? Right? So once I have that, I can transcribe that into English language, and then I can use generative AI to construct the process graph. And this has been a very interesting use case for us, trying to sort of see if we can accumulate the knowledge within the enterprise in terms of graphs. And this brings me to this plot. So so typically industrial AI was very much focused on operations, right? So what should I maintain? What should I repair? What is my demand forecast? How should I manage my inventory? These are very operational decisions. What I believe generative AI is doing is it is taking us from operational intelligence to so-called organizational intelligence. It's a lot of information that was within the organization that's important to more senior executives. So can we tap that now? So can we think about the overall processes within the organization and make them more efficient rather than only the operations? And I believe what you're going to see is the push from here to here. And that is also one of the reasons why you see so much interest in sort of generative AI from the executives. I want to skip this slide, but this is something I might not be as relevant to everyone, but at least in an organization like Hitachi, how does it really, if you want to think systematically about how AI impacts any organization? So one is, if you think about any organization, there is a core function and there are support processes, right? So if I'm a manufacturer, then my core function is manufacturing. If I'm writing code, I say I'm a Google, for the most part, my core function is writing code, right? So, and then things like HR, things like procurement, things like legal are support processes. So if you divide your worldview into core processes and support processes, then AI plays a role in both. But the interesting thing to keep in mind is for your support processes, you can get a vendor most probably, right? If you want to do HR, there will be some HR software company that will be thinking about how to use generative AI for HR. But where you should focus on as an enterprise is on your core processes, because that's the thing that you know, that's your own IP. And if you can transform those, that will have the maximum return on investment. Then new solution service customers is fine. Then other way to think about it is what you're taking to market, can you enhance that with AI? So that is around new products and offerings. I want to sort of put a bit of a damper here, and this is, I borrowed this slide from last year's talk again. And if you think about this in the industrial context, what is the data that I have? I have sensor data, event data, maintenance records, operational data, and then natural language data, right? So in some sense, as you think about large language models, from an industrial context, there's still a limited footprint, because language as a modality is not that frequent as compared to sensor data or event data. So despite all sort of the noise that we see in generative AI and around generative AI, there are a bunch of use cases that are not touched today. And once you sort of start separating out generative AI from the transformer architecture part, then I think you will see more use cases. For example, we are using now transformers for time series data. But is that generative? Not necessarily, right? It's just using transformer architecture. But my point with this slide is to show you that if you think systematically again through the organization, through your operations, or especially industries, then not all the use cases are served well. And this sort of brings me to another slide I'm trying to reuse. So these are the challenges that we had listed several years ago in industrial AI. And I believe with generative AI, you're able to handle this one. This is at the bottom, incorporating domain knowledge. But some of the other challenges still remain quite as they were before generative AI came into being. And I think this is something, again, to keep in mind as you think about the applicability of generative AI and how ubiquitous it will be going forward. I'm trying to rush through that. And I think, but coming back to the question of auto GPT, I do believe that the big vision that we had very early on of combining multiple systems is something that generative AI will enable, right? Because it can work as an orchestrator of different processes. And if you could do that correctly, then you could start optimizing across larger and larger sort of systems. So any individual system might not use generative AI for optimization, right? We have to go back to old school optimization, but orchestration of those is what generative AI will do for you. So I want to sort of conclude with this. I think we already made the point, while generative AI is important, it's part of the picture. Traditional machine learning, optimization still play a very important role in the industrial context. It's still early days, and it's sort of something to keep in mind. What is true today might not be true tomorrow. Technology does not grow really linearly, right? So it is often a step change. And so don't think like what the powers that we see today will continue to grow linearly or exponentially or whatever, right? So we made the point about workers are beginning to have experience in the enterprise. And the barriers to adoption are legal, social, economic. And let's be responsible citizens. Let's do trustworthy AI, as we say in Hitachi. Thank you so much.
Thank you, Dr. Gupta, for a very insightful talk, sharing your experiences. We have time for maybe a couple of questions here.
Dr. Gupta, I was really impressed by your presentation. If you could talk to your younger self in terms of going into a profession, what would you tell yourself to do?
Actually, someone asked me this question, and I told them, don't go into programming. It's a very difficult question. I think sometimes someone told me this, like, systems thinking is going to be important. Right? So humans' ability to sort of find connections across multiple different domains and abstract them out is still something that we are good at. And our curiosity and our ability to ask questions is what distinguishes us. Right? So for example, if you think about ChatGPT gives the wrong answer, it never questions itself as to why it is giving a wrong answer. It just gives an answer and says, I'm done. Right? So in some sense, this I think higher order things is something that would still be relevant. The other thing which is very true, but I don't think you want to say that, is manual labor is still manual labor, right? So, but I don't think you should tell someone to go manual labor. But that is being untouched in some sense, in very many ways, by generative AI. Physical labor is maybe we all go back to being farmers.
You know, I know Hitachi also put a lot of safety in their operation technology. So how generative AI can help with safety, or because it's also become, it may, you know, with the current limitations,
Yes.
do you envision it can be fixed to ensure the safety in the industrial standard?
So one thing I forgot to mention in the manual example that we did, so we are doing grounding. So we not only give you the answer, but we also point out the page on which the answer is. And so the humans can have a quick check whether the answer is consistent with what's on the page. So that's just one example. There is some research in making, especially RAG. RAG has one advantage: it hallucinates much less than directly accessing LLM. So we're working on that as well. And I think you had something in your slides as well around generating test cases for security. And I think that is something that is applicable not just for code generation, but in general for generative AI use cases. So yeah, so those are some of the things that we're working on, but by no means is the problem solved.
I know you forget, that's why I ask.
Thank you, Fang, for that question.
Just was wondering, how would you answer your question that you asked earlier about copyright, especially with regards to R&D?
No, this payback time, but this is a very good question, and I think this is, so, okay, I will give the official answer, and I think later we can chat outside. But this is something that we are very concerned about. So as we are building our own domain-specific LLMs, we are quite concerned about what data we can use. And in some sense, we are tagging every data set that we are using with where it sort of exists on the boundary. So that in case we have to revisit, we can remove that particular data set as we build the model. So this is one practice they're trying to adopt. And Hitachi itself owns a lot of domain data, right? But this is something that is an open question. And the whole industry needs to answer it. Right? I think a few days ago I read that OpenAI is being sued by someone, by authors, by several authors, by some 40 authors, because they say they violated copyright. And if you're going to write text in their style, that's a violation of the copyright in some sense. So the legal the legal framework of this is still being meshed out. But my thinking is the way the technology is so powerful that the governments will typically not step in to stop this, because no one wants to be left behind, right? So US doesn't want to be left behind China doesn't want to be left behind US. So no particular government would want to stymie the development of these tools. So this is going to be a very interesting dance over the next several years.
Great. So I had one quick observation, since you used a few slides from last year. You had a slide there with the deep learning architecture last year. You said, I put this in there just to look cool. So I was wondering which one was that.
The 5 design patterns is the only.
Design patterns. All right, great.
If you ask me in detail, I would not know much about it.
There you go. But thank you once again, a small token of appreciation for being here, and a great time.